Double check that I am recording from the microphone. Sometimes I forget to check this step and it will just be silent. When you watch it, it's like, just screen stuff but with no sound. Alright, so this is all working and we can now go to the website. I just want to show you your homework assignment, so this way you know where to find it and what to do with it. When the iPhone 4S or the 5 first came out, somebody wrote an application on the iPhone where, if they put an iPhone next to a keyboard, by measuring the delay of the tapping, they can infer which key you are pressing on the keyboard, and therefore be able to kind of guesstimate your password. Have you guys heard of that? Okay, it's not 100% precise, but from the they can kind of guesstimate what the key sequences, common key sequences. So it uses a little bit of a fudge factor to make it work. Since we're talking about security, I just thought that I can bring that up. All right, so we are in ciss342 right here. All right, so your first homework assignment is right here. It's called set up VirtualBox. The way it's set up, I can give you a preview. It has basically like 4 questions or something like that, and there are 3 people attempted it already. So when you attempt it, you basically have some instructions. It will ask you to do something, and then when you're done with those steps, or after you read the instructions, it will ask you a question. You just have to answer the questions. I would suggest you to answer the questions in the correct order, because if you try to answer it out of order, it may not work well, because of that. And the I here, when you see I, it is just an information page. It does not have a question on those pages, but nonetheless, you should still navigate through the questions, in sequence and not do it out of sequence. This is the website of VirtualBox. So if you go to virtualbox.org, this is where you can download VirtualBox and have it installed on most platforms. In other words, you can run it in Linux, in Windows, Linux, Mac OS X, and Solaris. Yep, go ahead.
I have a little bit of an issue. I have a computer that is not mine.
Okay.
That I don't have any admin privileges on.
Oh,
I can't
okay.
install anything on.
Okay.
So I have no box besides those that I have access to at school, and the boxes in the library and such don't have VM.
I think VirtualBox is probably installed in room 152, so you can still do the homework in room 152.
That's the Mesa room?
That's the main computer lab. And then the other thing you can also do is to use my distribution, because I have VirtualBox also installed on my distribution. Can you reboot on the machine that you have access to from USB?
I should be able to, yeah, but in order to do that, I have to install it, which is what I'm trying to do now.
Okay.
So,
if you do not have administrative right, I know for sure that you cannot install VirtualBox, because it has to install certain drivers for sound and also for network. So that means if you want to install VirtualBox, you have to have administrative right on that machine. If you do not, then the best bet is to use my distribution, because my distribution under systems now has, I thought it has VirtualBox installed. Oh no, what happened to VirtualBox? Alright, maybe I... Oh, okay. I thought I had VirtualBox installed on my live distribution. Apparently it's not there. I will go ahead and fix it, as soon as possible, and then re-release it, on the website. So VirtualBox is the virtualization technology that we'll be using, and unfortunately, since it's not installed on my machine, let me see. Let me just double check. Since this is a Linux class, it's helpful. This step is actually a part, quote unquote, a part of the class. is how do you know what package is installed? Now, this works in Debian. It also works in Ubuntu or anything that is Debian based. I know most of you know the GUI part, of how to do it, but we'll do it on the command line and use aptitude instead. There are at least 3 command line programs that you can use to check packages, to install packages, and so on. Aptitude is one, deselect is one, apt-get is the other one. Okay, so there are at least these 3 that you can use to install packages. And this is one of the things about Debian, or the Debian type of distribution, that is really kind of nice because upstream, which means Debian, Ubuntu, and the other organizations, they have packaged all of these applications and other programs and services into packages already. So all you have to do is to run a program like aptitude in order to install additional ones if you need to. So I'm just looking up VirtualBox. It should be installed, but it's not showing up on my applications menu. So I'm just not 100% sure. Maybe it's just not overwriting the files correctly, but that's okay. We can always set it up, manually.
I know that in my old setup, sometimes you have to reboot in order to see different things.
Yeah, but I just reboot it into here, right?
And you just run it from the command line, just type in VirtualBox.
Yeah, but it doesn't have that either. VBox. Yep, VBox, I guess. VBox manage. Is it uppercase V? Yep, VBox. No, it doesn't have VirtualBox. It has VBox. Okay. It says the device VBox driver does not exist. Please install the VirtualBox DKMS package. And I thought I had it installed already. Okay, let me.
If you use apt-get, it will install the Qt dependency too, so they'll get the GUI interface, make it easier.
Was that a search engine? What's your top?
Hmm?
The first one. Yeah, the first one.
No, this right here. What is this?
This is aptitude. Okay, let me just kind of back up here. What I did was I used SU to change to super user. So this way, all the commands that I execute at this point will be from an administrative account, so I can actually do type system administration. Aptitude is the program that I use to check what packages are installed, and then if it's and install additional ones if I need to. And I use / to get into the search mode, so this way I can search through the thousands of packages that are available for the one that I need to use. And as you type, it will search already. And you can use lowercase n to get to the next one. And aha, okay, so this one is not installed. I have to install these additional ones.
Slash to get to the
/.
search. Oh, slash.
Yep. And this one is not installed. That's why the GUI part is not installed. They're no longer used. Alright. Well, this is how we install additional packages. I just remade the ISO image last night, so yeah, it takes a while to to get it working. While we are waiting for this, we'll go ahead and get back into the class material. We can talk about something that does not depend on VirtualBox. So we'll start with topic 2. And with topic 2, we start with what exactly is a Linux client system, because if you remember the course syllabus for this class, in terms of the student learning objective, we are only seeing things from the client system perspective and not from the server perspective. So we want to kind of take a look at what is Linux, what is a client, and why is it any different from other general systems. All right, so the first question is, what exactly is Linux? Does anyone want to answer that question with like 2 sentences?
Operating system.
It's an operating system, and how is it different from, say, Windows or Mac OS 10?
It's open source.
It's open source. Okay, very, very good. What does that mean? When we say something is open sourced, what does that imply?
It's free and you can add to it or change it at your will.
Very good. Okay, you capture both attributes of open source. It is free as in free beer. It is also free as in freedom. Okay, so that's how most people remember how what is open source. It is free in 2 senses: free as in free of charge. You don't have to pay for it, and then free as in freedom, where you can make changes to the source code, redistribute your modified version, and that's that basically defines the essence of open source. Okay. So you can click this link also to get to linuxfoundation.org and find out more about Linux. I'm not going to go there, just because we don't need to know that much about Linux, for this class. And as far as open source is concerned, there's opensource.org that you can also go to in order to find out what licenses are considered open source compatible, because there are licenses and there are licenses that are not open source compatible. And we have a short list of examples of how Linux is used. So I just want to kind of bring this to your awareness that Linux is not really just a client system. It's actually useful for many, many different applications. The first one has to do with cloud network enterprise servers, which is something that I would mention in this class, but not necessarily get into too much, because it's definitely not a client system. Many web servers and database servers use Linux as an operating system, and guess what? Even Oracle, IBM, and HP, they use Linux as the underlying operating system for their servers. For many years, IBM has AIX, which is a Unix derivative, for IBM machines only. HP has HP UX, which is a Unix variant for HP servers only. And I would say about 8 or 10 years ago, both companies decided at about the same time to switch to Linux. And basically they say, well, why would I want to pay my own developers, my own software department to develop my own operating system when I can leverage out of an open source project and have basically worldwide support of developers to help me develop this operating system. So for years, up to now, I think I would say about 10 years, for about 10 years already, IBM and HP particularly have used Linux, and both companies have also contributed back to the open source community. Okay, particularly IBM, they have a lot of stuff they put back into the community. You're basically saying, okay, we developed this stuff here, we'll put it back into the open source community where everybody can use it. Okay. I'm not going to get too much into the whole philosophy of open source because it's not really the focus of this class. The LAMP combination, is mostly useful for, kind of like homebrew servers. I would probably not use this if you have an enterprise level type of server. But if you have a home server, or if you want to just, serve 1 or 2 websites, the LAMP combination is actually pretty good. LAMP stands for Linux, Apache. The M part usually stands for MySQL, and the P part can be PHP or Perl. Okay, but they're all open source projects. In other words, if you look at the entire stack of software for LAMP, they are basically all free. There's no proprietary software with LAMP. So you can, for smaller websites, this is basically, you have the software for free. You just have to rent time for the server, and you can have your basically website up and running. How many people manage your own website somewhere? Okay, do you have your own physical website, or do you have it hosted by somebody? No, physical website?
Yeah, I have a LAMP server.
Okay, at home or?
Yeah.
Okay, I used to have one until the district shut it down. Actually, I still have it, except I cannot run Moodle from it. So that's one thing that the district has asked me to do is to move Moodle from my home server on into the infrastructure of the district for security purposes. The premise was I was told I was asked what if someone breaks into my house, go straight to my study, look at the really archaic box sitting under my desk and say, wow, that has a lot of student information. I'm going to steal that, ignoring everything else. And then maybe I'll sell that information for money. Maybe I can blackmail these students and say, you know what? I'm going to tell your mom that you failed this class if you don't pay me $500, right?
Sounds really probable.
Yes. So I told the director of technology at the time and say, well, thank you for the concern of my family members, but I think the server is relatively safe in my house because there's definitely more valuable stuff in my house that they can get other than a box. I mean, who would steal a desktop computer these days? No one, right? I mean, it's like, why would you even look in that direction? It's like, wow, that's a big box. Okay, move on. Maybe they'll open the box, because I might use it as a secret safe. I might actually have stashes of gold nuggets inside. That would be the only way to use a physical box like that, right? Well, at a larger scale, if you're actually running an enterprise level type of server, Linux usually is only used as an operating system with proprietary software, taking the place of MySQL. So in this case, IBM has DB2, Oracle has Oracle, and then HP has their own SQL server. I cannot remember the name. In recent years, cloud-based big data applications obsolete the more conventional relational database model. Once again, I'm not going to get too much into this, but basically, what we understand as a relational database has limitations when it comes to storing, like gigabytes and gigabytes of storage. It is not efficient, and it does not really lend itself to clustering when we have relational database. So for bigger databases like what Google has to maintain, it's called big data. And big data has a slightly different model where data is stored on multiple servers, and it lends itself to having a cluster of servers to manage all the data. But for our purposes, we just have to understand that so MapReduce, if you look up that term, you will find lots and lots of literature related to big data. And there are open source projects implementing MapReduce also under the Apache open source license. So for those of you who want to kind of experiment with big data technology, you can actually do it too. I mean, you can actually run 5 or 6 servers as a cluster and just kind of play with MapReduce technology and understand what big data is really all about. But for this class, we just have to understand that Linux is also used as a foundation operating system for big data, even though they do not use relational databases anymore. So that's basically one application of Linux. It's used for big servers on the net. The other one, I think most of you already know, is if you have an Android phone, you are running Linux. Android has Linux as the foundation operating system, and on top of that, they also implement a Java virtual machine, and also on top of that, they have their framework, their application framework. But if you look underneath, at the foundation level, it is Linux. So what that means is what you learn in this class, some of the security stuff that you learn in this class, also applies to Android. If you install a terminal app on your Android system and you have it rooted, you can actually run some of the commands that we learned in this class. Although typing, on that little screen can take a little bit longer than a regular keyboard. The reason why Android is a foundation layer of these mobile devices, well, there are several reasons. One is it is a cross-platform operating system, which means Linux, for many years, has supported multiple architectures. In other words, if you look at Windows, what processor can run Windows? the x86 family, and recently the ARM architecture, but not much else. When you look at the computer architectures supported by Linux, it's a long list. It's a relatively long list, with really archaic processors that are research only. Okay, you only use those processors in the research lab, to common processors like the ARM processor and also the x86 type processor. The other part why Android uses Linux as a foundation operating system is because it is open sourced. Linux does not cost anything for licensing. Had a question?
Oh no, sorry.
No? Okay, that's okay. And then third, Linux is open sourced, which means with Android they can make additional modifications to make it work well on mobile devices, and there's no need to ask quote unquote somebody else to do it. Okay, because anyone with access to the source code and the know-how can now go into the kernel and say, oh, I need to modify the kernel so that it works this way or the other way. With my other classes, I usually have quite a few gamers in the class. I'm not sure how many of you are gamers, but with Steam, they are releasing Steam OS, which is also Linux-based. They're using this for the Steam boxes. They're essentially set-top boxes for gaming purposes. But once again, we have those two main reasons why it is chosen. One is open sourced, and two, it is open sourced, and therefore it is free for one reason, and then two, you can also modify it for those other two reasons. We have desktop and notebook computers. Not really common. Okay, it's getting more common these days. But in the past, if you run Linux on your desktop or a notebook computer, people look at you kind of funny and go like, why would you want to do that? Well, I got a few reasons why you might want to do that. Linux is really more efficient with resources. So that's my number one reason why I install Linux and run Linux, especially on older computers where Windows 7 just runs out of steam. There's not enough processing power or RAM in order to use Windows. Now, I can show you, okay, this is all done. Nice. Okay, I can show you how much resources is being used at this point, and this will come in handy at some point as well if you're assessing the security of a system. But for the time being, I just want to show you how much resources is being used. This computer has 8 gigs of memory. If you look at this part here, that's measured in number of megabytes. Or kilobytes, sorry. This is measured in number of kilobytes, and that adds up to 8 gigabytes. It's using 4 gigs right now, which seems a lot, but out of the 4 gigs, 2.5 gigabytes are used as cache, so it's not really actively used. It's only there to speed up access to files. So that means if you look at 4.3 gigabytes minus 2.6 gigabytes, I'm using about 1 gig of RAM. Okay. Which is surprisingly high, huh?
It's just that including the recording too, which makes it a little bit higher.
Which is including
The recording.
Including, sorry?
FMPEG.
Oh, okay.
Recording.
Yeah, well, that one doesn't take up that much. I mean, you can look at the virtual memory size that it's using. It's not really all that much. I'm kind of surprised that it's using close to, it's one point something gigabytes right now. Yep.
I noticed that you're not using ARP on.
I'm not using.
ARP on. I think it's called ARPON, ARPON.
Oh, okay.
Okay. I was gonna ask. I had that program running. It was taking up 90% of the processing.
Oh, okay. ARP is a networking thing, right? ARP. Okay. If you run any type of sniffing, network sniffing type of application, that can take up a lot of processing time depending on how busy network traffic is. Later on in this class, we'll talk about Snort, which is a network sniffing. It's called an intrusion detection software, IDS. Depending on network traffic, that can soak up a lot of processing resources. So that's why if you want to run something like that, you've got to make sure that you have the horsepower to do it. Okay. All right, let's keep going here. How many people know what is a Raspberry Pi? Okay, there are a few. For those of you who do not know what is a Raspberry Pi, let me just show you a picture of what it is. the picture itself is not impressive at all. I mean, it's like, okay, it's a circuit board. If I just type in RAS, it pops up. Raspberry Pi is the second item or the first item. And it's really is a lot. It's a DIY kind of thing. Somebody made a xylophone player out of a Raspberry Pi. And now I want to click it. I know it has nothing to do with security, but it's just out of curiosity. It's like, what does it do? Curiosity and security sometimes, do not mix. I want to see what it does. Click it, and then your computer gets infected. It's like, don't. I think the rhythm needs refinement. Programmers sometimes may not be the best musicians. Yeah, I think that's it needs a rest somewhere. All right. So the circuit board. Using Minecraft Raspberry Pi Edition to get kids computing, you can actually run Minecraft from a $25 Linux box, basically. If you want to get a Raspberry Pi, you'll be surprised at where you can find it. You can actually go to Amazon.com and look for Raspberry Pi. They may not have the best prices, but they do have it. Because I just want to show you a picture of this, That's basically a Raspberry Pi. It looks just like a little circuit board. It has HDMI output, has network interface, it has a USB port here, and I think that's audio port or power supply, another USB port over here. So it doesn't look very impressive, but it can run Linux. Okay, so you basically have a, if you add shipping to it and taxes, probably a $40 computer that can run Linux. Doesn't have a screen, okay? Does not come with a screen, but you can hook it up to various kind of stuff and look up, what people have done with a Raspberry Pi. It's really quite interesting. Low power consumption. There's no heat sink. You don't see a big, huge fan here because the heat dissipation is not an issue with this particular Linux box. And best of all, you can run Minecraft. So next time when your kid or your nephew or cousin asks you, well, can you get me a box that can run Minecraft? Sure, here's a $40 box. Hook it up to the computer, hook it up to the TV and the stereo, and here you go. You can run Minecraft. All right. Virtual machine server, okay? For industrial strength, you want to use something from VMware, like a ESX 4.x type of operating system. But if you want to do something homebrew and just say that I just need a box that has enough processing power and enough processing resources so that you can run. Okay, let me tell you a scenario why you might want to consider running your quote unquote virtual machine server even at home. Okay, how many people know that well, maybe I want to install, let's say, Creative Suite 6, CS6 from Adobe. That's an expensive, program. How much do you pay for CS6 these days? Full install. $600, $700, something like that. Okay. So let's just say that in your house, you want to do it. Sometimes you want to use it in your study, and other times, you want to use it, on your laptop computer, and other times you want to use it in your bedroom. Okay. So you want to basically be able to run the same program on different machines, depending on where you are. Okay, is that okay? All right. So you have several options. One, you can use a laptop computer. Install CS6 on a laptop computer and just carry that around. how much processing can you pack onto a laptop computer? Quite a bit these days, but they tend to run hot, and also the longevity of a laptop computer is not really quite as good as a desktop computer. You can install multiple versions. Okay, you can install one on the laptop computer, one on the desktop computer, but that will cost you extra money because now you need multiple licenses. So one solution is to run Windows as a virtual machine and then install CSX on the virtual machine. Now you can run that virtual machine on a really powerful box. Okay, you can put together a reasonably powerful box using, let's say, an Intel i7 processor, put in 16 gigs of RAM, lots of storage and stuff like that. And then you can use the network to connect to the virtual machine. So now you can run a really, really primitive, old laptop computer, but most of the processing is not done on the laptop computer itself. It is quote unquote a dumb terminal for all purposes. The actual processing, rendering, and all kinds of stuff is done on your super duper box, that you have, sitting somewhere else in your house. So now, when you're sitting in the living room, you can use your 60-inch, HD, 1080p, HD TV as your monitor. Okay, when you're using your computer, your laptop computer, you use a laptop computer. When you're on your desktop computer, you use a desktop computer. You can basically go to any computer in your household, network to your virtual machine server, and be able to connect to the operating system running Creative Suite 6. So that gives you a certain advantage. I mean, now you have the convenience to do all that stuff, and also on top of that, you're not locked down to a single machine anymore. Okay, so that's why a virtual machine server can come in handy, and Linux can be a candidate as an operating system for a virtual machine server. Okay, so with all that stuff talked about, what exactly is a client? We talked about that a little bit in the previous class. In this context, a client means a system only has or mostly has client applications or client programs. In this class, the term application is about the same as the term programs. Okay, so I would use these terms interchangeably. In networking, a client application is a program that initiates a network connection to another application, possibly running on the same system or another system. Right now, I'm using a browser. A browser is a client program. In other words, whenever I click on something, let me just click on something here. Whenever I click on something, like this click here, this computer is sending a request to the website virtualbox.org saying that I want to bring up these images and bring up this document here. And then the server is the one that is responding to my request and come back with all these content that I can render on my screen. So a web browser technically is an HTTP client program. Okay, we just unofficially call that a browser, a web browser. Okay. And for the purposes of this class, a client system is one that does not accept requests from an external system, or for the most part does not accept requests from an external system. So that means we're not going to run a database server. We're not going to run most of the server programs, with the exception of SSH. Okay, so SSH is one of the server programs that you might find handy even on the client system, because you can remote into a computer using the network to do all kinds of stuff, useful stuff. And also, for all practical purposes for this class, a client computer is one that is used by quote unquote an end user. So this class is definitely end user oriented and not server oriented. All right. So are there any questions about this particular slide here? Well, not a slide, but this document. Okay. No questions? If there are no questions, we'll move on to the next one. All right, we are still in topic 2. Okay, so now we're going to get into a little bit more networking concepts. It's really important that we go over these concepts before we actually start to do anything with networking. But I'm going to get out of this one a little bit here because the installation is already done. So I'm going to look up and see if VirtualBox is already installed. Excellent. Okay. Do you remember this screen earlier when I was still in Windows? Looks exactly the same here. And then the first thing I want to do is to go to Preferences and go to Network and make sure that I can add a host-only network. Oh, I just need one. There we go. All right, so that's good. I just double check and verify that we can do all this stuff here. I'm going to remake another ISO image, just so that people who cannot install VirtualBox in Windows can run the Linux version of this and still be able to get the homework done. Okay. All right. So sorry for the digression. Coming back to network ports and connections. So it is really difficult to talk about security if I do not first introduce concepts of networking and also communication between processes. So what we'll do is we'll start with TCP. TCP stands for Transmission Control Protocol, and what it does is this sentence here. Okay, it allows what we call a client process to initiate a connection and connect to a server process. A process, in this case, is basically a running instance of a program. Okay, well, that's great, but Tech, did you forget to mention something about communication between computers? What do you think? Can I use TCP? Sorry, go ahead.
I was going to say it can be on the same machine.
They can be on the same machine, exactly. These two processes that need to talk to each other, they can be on the same machine. They can also be on machines that are half a world or across from each other. Okay, so there's no difference in terms of the technology involved. The server is the one that can accept or reject a connection. Okay, you have an incoming request to connect, and then the server can say yes, connection accepted, or I deny connection. Should the server accept the connection, then what happens is a socket is created in order to represent the established connection. The connection is also a two-way connection, which means it permits asynchronous communication between the server and the client. Okay. Are there any questions about this paragraph? Because there are quite a few terms that I have thrown into this particular paragraph here. No questions? Okay, later on there's an analogy, so I'm pretty sure by the time we get to the analogy, we will be able to understand the concept a little bit better. Local processes. When the client and server processes are on the same computer, the address of the server application can be identified as a file. Okay? In other words, if the server process and the client process are running on exactly the same machine, they can use what we know as a file as a common place to communicate. Okay, the client process can initiate a connection, and say that, hey, I want to make a connection. Do you guys have a question? No? Okay. So the client process can initiate a connection and say, okay, I want to start a connection. And then the server process can look at the socket, which is in the form of a file, and say, okay, who's making a request to connect? And then the two process can do the handshake and make a connection. But it does require that both the server process and the client process to be on the same machine so they can see exactly the same file system. Okay? It's a very handy way to do things, but it has limitations. Because what if the client process and the server process are not on the same machine? Then they cannot share the same file system. If they cannot share the same file system, how do they find each other? How do they find the connection point? Okay, let's forget about networking and security and Linux and stuff like that. Okay, in real life, how do you communicate with somebody who's not physically here? What is the, sorry, go ahead.
Phone call.
Phone call, okay. So what do you use to call up somebody? I really asked a very dumb question because these days it's a little bit different from what it used to be in the past. But go ahead, explain to me, how do you call someone?
Dial their phone number.
Dial the phone number. All right. So the phone number is the identification point. Okay, because so whoever is placing the phone call is the client process because you are the one initiating the connection. You are the one requesting a connection. Okay, you are the one who's dialing the number and say, okay, I want to talk to you. Okay. On the other side, the server process is the person who owns that phone number. Okay, and that person, as a process, quote unquote, as a process, can look at the incoming phone call, look at the caller ID, and say, nope, don't want to answer, or yes, I want to answer the call. So as a result, that person has the option of refusing the connection or accepting the connection. I'm using this motion because that's how I do it on the Android phone. I slide that little thing, one way to hang up or to reject a call, and slide it the other way to accept a call. Okay, so I just want to explain why I do that gesture. But that's really the whole point. Okay, the phone number is analogous to what in networking?
IP address.
An IP address. Yep. What about domain names? How does a domain name relate to an IP address?
Caller ID.
Caller ID, or these days on a smartphone, you can just say, call somebody, right? So that name is quote unquote the domain name because it makes sense to you. Okay, mom, dad, okay, Johnny, Joe, okay. It makes sense to you because those are people that you know, and the phone number is not something that we can remember easily because it's a whole bunch of numbers, a bunch of digits to us. So it's the same thing with a website. What is the IP address of the power server? I'm hoping that nobody can remember that, so I can make that point. I can remember because I use it often. Okay, the power server has an IP address of 165.196.78.8. Okay, but most people cannot remember it, right? But you can remember power.arc.losrios.edu, even though, yeah. So you can remember that because we are used to arc.losrios.edu already because it's an educational institution. It's the Los Rios district, and this is ARC the campus. So if I just want you to add power on top of that because that's the name of the server, hey, most of you can probably remember that after using it twice. But if I want you to remember the IP address, which is 165.196.78.8, it probably will take you 10 times or so to remember that. It's the same thing with phones. Okay, if you have a smartphone, you can say call Joe. That's the domain name because it makes sense to you. It's easy to remember from your perspective. But then the phone has to look it up and find out, okay, so what is the actual phone number of Joe? Okay, then it has to look it up and find out. Right. So let's go ahead and get back into this topic here and talk about remote processes because now we have to talk to another process that is not on the same machine. So the Internet Protocol is the underlying protocol under TCP, and IPv6 version 4 specifies that communication endpoints have a 32-bit address. In other words, when you place a phone call, inside the United States we have 3 digits for the area code and then 7 digits for a phone number within the area code. So we have 10 digits for a phone number, and for IP addresses we have 32 binary digits to represent a particular endpoint. Now, it doesn't mean that we can use the entire full range of bit combinations. Certain bit combinations, just cannot be used. Just like with phone numbers, you cannot use all possible combinations using all 10 digits. This address is further separated into a network address and a host address for routing purposes. Just like with an area code, that's kind of like your network address, and then within the area code you have the quote-unquote host address for identification within the area code. This allows 2 computers connected by IP on different network to connect by other networks, and hence the name the Internet. Okay, because we can now route traffic from one network to another network. Now this part is important. In addition to an IP address, a connection, if you want to make a TCP IP connection, you also have to specify a port number. Okay, so you have the IP address and then a port number. Just like when I want to make a connection to the power server, I can specify the connection like this: 165 196.78, oops, 78.8. That's the IP address. But on top of that, I can also specify the port number, after the colon. In this case, I can specify port number 80, which is conventional for HTTP on the server. So, and now I make the connection, I bring up the web page, hey, that's all good. So the question now is, what exactly is a port number? If you want to use the analogy of phone numbers, a port number is like an extension. Okay, it's like an extension after a phone number. I'm just going to pull up my credit card here, and it has a phone number to report issues with my credit card. So after I call that number, most of the time with credit card companies, they allow you to quickly enter an extension number if you know the extension number, right? So what does an extension number do on top of the phone number?
It routes to all the specific phone.
Sorry, say again?
It routes to all the specific phone.
Right, it connects to a specific quote-unquote phone inside the organization. But most of the time, it is not a particular phone, it is a particular service. Okay, to report lost cards, okay, it might have an extension number just for that. To request, extension of a credit line, that it probably has a separate extension for that. Okay, it's the same thing with port numbers. Okay, so each port number, quote unquote, has a special purpose. Port 80 is for HTTP, is for serving web pages and stuff like that. Port 22 is SSH. Port 443 is HTTPS. Okay. What about port 25? SMTP. Port 21? FTP. Let's see. What else? What else are common ports? Go ahead. 23 is Telnet. Okay. What about port 143? SMB.
Instant messaging product, so
IMAP.
143.
143. I thought it was SMB. Which port does SMB use?
SM25?
Sorry?
25?
25? Nope. 25 is SMTP for email servers. Okay. I'm just trying to remember your port numbers just out of my head. Those are the common port numbers, and you can usually look up a map of port numbers and the service usually tied into that port number. Unlike an extension, because the extension for reporting a lost card for a Visa card can be different from the extension for American Express. Okay, but for port numbers in computers, they are the same. In other words, it doesn't matter which web server you're connecting to, port 80 is usually the one associated with HTTP. So you can connect to eBay, it's port 80. You can connect to Amazon.com, it's port 80. So it's a very common thing shared by any number of for all the servers that need to serve a particular purpose. The port number is what is identifying that service. Right? So we are currently at this point here. When the client and server processes are on computers connected by IP, a socket is identified by an IP address plus a port number. So basically a socket is an endpoint, is how you identify, okay, where am I supposed to connect to? It is the IP address identifying the host. Well, not actually the host. The IP address is only identifying an endpoint, and then you have to add a port number to basically say, but what service am I requesting out of that endpoint? Because an endpoint is simply saying that I'm here. This is the phone number of Wells Fargo. But what do you want to do when you call Wells Fargo? I want to check my balance. Okay, use this extension number. I want to extend my credit line. Use that extension number. I want to report a lost card. Use the other one. Okay, use another extension number. So that's basically the same thing with networking, except we have port numbers instead of extension numbers. A server process listens to an IP address plus a port number. Okay, now this phrase by itself is also important because what that is telling you is when you expect a server to be responding to something, it has a program in execution, a process that is quote unquote listening to a particular IP address, and on top of that, a port number. Basically, a specification of an endpoint of TCP/IP connection. Okay, and the client process would use that address, which is the IP address plus the port number, to basically say, okay, I want to make a connection to that particular endpoint. Are we doing okay so far with those concepts? Okay. And here we have the IP address, versus phone number analogy, which we talked about a little bit earlier already. And this is an example of what is going on when you just click a link on a browser. Okay, so we are just using this as an example of using this as a URL, a universal resource locator. HTTP is specifying the protocol. In other words, when you use Chrome or Firefox or most of your browsers, you can specify a different protocol. You can specify HTTP for Hypertext Transfer Protocol, or you can specify FTP for File Transfer Protocol. Okay, the protocol is simply saying, okay, we're going to use a different language to specify what I'm trying to request and what is the reply. HTTP has its own specific way of saying, oh, okay, what you're requesting does not exist. Okay, that one we know a lot about, right? We get it a lot. What is that? 404, exactly. And FTP has a different code to return when it cannot find the file that you're requesting. So that's basically what the protocol or the transfer protocol is about. It's just a common language so that you can specify what you're requesting, and then the server can tell you, okay, do I have it? And here it is, if it is there. And then we have either the domain name or the IP address. In this case, I specify the IP address. A domain name is nothing more than a formatted name that can be translated into an IP address using a DNS server, okay, or a DNS service. You can translate a domain name into the IP address. So everything boils down to an IP address eventually in order for TCP/IP to work. And then this part here is the port number that we are trying to connect to. So in this case, port 80 usually is not required because port 80 is the default port of HTTP. 443 is the default port of HTTPS. So in most cases, if you don't specify the port number, it already understands from the protocol which port should be used. Are we still doing okay at this point? All right. So I have just explained, this part here. Okay, so I'm gonna continue after this point. As soon as you press the Enter key on the browser, a TCP request to connect is sent to the socket identified by port 80 of this particular IP address. On the router, a process, in this case an HTTP server process, has been listening to the port 80 of this particular port. I use a router here. I use the word router instead of a server because that's usually how you communicate with a residential gateway. How many people do that at home? You configure your residential gateway for Wi-Fi connections and stuff like that. Okay. So that typically, depending on the company, they pick 196.168.0 as the network address. Some companies pick 192.168.1. So depending on the company, that can be it can be a little bit different. So a process running on the router will be listening to this particular port of this IP address for incoming requests. Note that this part has nothing to do with HTTP. In other words, at this point, it is IP working, not HTTP working. Okay, so IP is the underlying protocol, and then HTTP is on top of that. Once you have the connection, then HTTP becomes useful. Right? The HTTP server process on the router decides to accept the connection. A connection instance socket is created to represent the newly established connection between the client process running on the PC and the server process that is running on your router. In other words, if I want to draw a picture representing what is going on here, you have your, let's say, laptop computer here, and then you have your Wi-Fi router sitting here. You have two processes in this communication scheme. You have one process running on your laptop computer, which is represented by, let's say, Firefox or Chrome or something like that. It is a web browser, an HTTP client. You have another process running on your router that is representing the HTTP server, which is going to serve out the content. So the way it works is the request, first of all, there's a request going in this direction, and it will identify 192.168.0.1, port 80, and this process has to be listening to that particular port number on this network port. If this server decides, okay, I'm expected to answer to this request and accept the connection, then the connection is established. Okay, and this is all done at the IP level, the Internet Protocol level. What if you have multiple connections? What's going to happen then? In other words, what if you have another computer in your household? Okay, here's another computer running its own browser, and it decides, I want to make a connection to the router at the same time, going to the same port, the same IP address. What do you think will happen in this case? Both requests are going in at the same time. In other words, what do you think will happen?
It moves the connection to a different port for communication.
Nope, it does not. Okay, what do you think happens when multiple people call up Wells Fargo and request going to the same extension number to request the same service?
Put on hold.
Well, yes, that is one option. Hopefully you're not going to be placed on hold. Okay, for any large organization, at the same extension number, they can have multiple operators responding to that one single extension number. Okay, in this case, what is happening is, I know it's confusing because the term is also a socket. When you have two simultaneous connections going in, the server process would actually spin up one process per connection. So you have one process to handle this communication with computer A, and then you have another process, another socket instance to communicate with computer B. Okay? In other words, there is one process acting as a manager at the extension number. And then what the manager is going to do is to say, okay, we want to accept this connection. Let's see here. Okay, operator 20, you're going to handle this call. And then redirect the call to operator 20. If another call comes in to the same extension number, the manager would look at that number and go like, oh, okay, I can see operator 20 is busy with this call already. It's ongoing. And then the manager can say, oh, operator 23, I can see that you are free. I'm going to direct you to operator 23. So operator 20 is a socket instance. Okay, it's operating on one particular instance of a socket. It's serving one instance. And then operator 23 is another process surfacing another connection at the same time. Are we doing okay so far? Well, since I'm teaching this class, I can kind of assume that most of you have, visited Fry's at one point or another, like this afternoon or yesterday. The server process that is actually doing the management is the person at the head of the line directing people to the multiple counters. Okay? And then the counters, the people at the counter, are the ones that are actually serving the connection or processing the connections. Now, what if you have only 5 counters active, and then you have 20 customers? So you would use up all 5 counters right away. So what happens to customer 15? Well, I should count forward. Okay, what happens to customer 6? Customer 1, 2, 3, 4, 5. They get to counter 1, 2, 3, 4, 5. They're all getting served. What happens to customer number 6? Has to wait.
They complain if their internet is broken.
Yes, they can complain all they want. Yep, they have to wait. It's the same way here. Okay, so if you have a lot of computers trying to make the connection, the server process has the ability to say, well, I can only spin up X number of processes to process these connections at the same time. If any more tries to come in, I'm going to hold it off until one of the processes is freed up because that connection is now done. Okay, is that okay so far? Okay. So that's basically what I mean by multiple instances of sockets, because each one is representing an actual connection. The web server, web browser, excuse me, would get the acknowledgement that the request to connect is granted. So this is still happening at the IP level and not HTTP. The connection instance socket is now created. In other words, you are now at a counter at Fry's. So now there's one protocol to establish the connection, which is basically saying, okay, you go to counter number 5. That is one protocol. Okay. Once you get to counter number 5, the transaction between you and the person behind the counter is another protocol. That's HTTP in this case. Okay. So at this time, the web browser, once the connection is established, the web browser will send the HTTP request itself to the server process. Which document in which folder are you requesting, or which script are you trying to run with what type of parameters? So at that time, the web server application or process will get a request. The HTTP server, in this case, is in the software sense, not in the hardware sense. So this is a process doing the HTTP serving. Will interpret the request. It will retrieve the requested document, assuming it's a simple, just a document request, and include it as the reply back to the web server process. So it will send it back to the web browser in order to, so the browser will get a document. When the browser receives the reply, it will extract the HTML document from the packet received and then render it, as the last step. So this basically shows the entire process of what happens when you type in a URL at the request at the address bar and press the enter key. All right, are we doing okay so far? You have to remember Wells Fargo and Fry's. So between those two, I think we got all of the concepts, handled. Okay. So here, we have just, a clarification. I think we can skip this because I think I sufficiently explained this concept already. Now, for security purposes, we have about 7 minutes left. Let's do some command line stuff, so that we can kind of do some assessments, okay, of what is going on here. All right. So I'm running as root here. This is on the command line. This is all getting recorded, so I wouldn't bother to kind of write everything down because by the time you write it down, it's already gone, right? You kind of have to focus on the concept, not the details. Okay. Okay. There are several things we can do. The first command is called top. What top does is, well, it shows you what is using processing resources. By default, it will list the process that is using up the most processing time on top. In this case, it's FFmpeg, which is the software that I'm using for screen recording and transcoding at the same time. And that's why it's chewing up so much time, because I'm also transcoding everything. The next one is Xorg, which is a process responsible to display stuff on the screen. And then we have post audio, which is the audio processing thing, and that one is responsible to take the feedback from my USB microphone and process the audio information. And then Chrome obviously is the browser. So these things are taking up the processing time in this order. FFmpeg is taking about a quarter of all the processing resources of one core. Okay, so these are percentages of one single core. If you have 4 processor cores, that means you have quite a bit more processing power available. I'm only using like a tiny bit of all the processing resources available to me. Okay, so this is useful, but if you really want to know what is going on or what processes are running at this point, this is not useful for that purpose. What will be helpful in this case is PS-uppercase A lowercase l. There are variants of this that you can find useful as well. But this command, ps, can list all the processes that are active right now at this point. Okay? Remember, the communication between the client and the server are between processes. So in order for any communication to happen, or in order for something to wait for something, to listen to a port, you must have a process corresponding to that. So PS, dash uppercase A and lowercase l can be helpful for that. So in this case, I can look for, okay, let me just go back here. This particular command is actually a combination of two commands. The first command is ps-al. It listed all the processes, but it will list it. It's going to be a long list, and it will be out of this entire area. I can use the scroll bar to scroll back and whatnot, but less as a pager is actually much more useful because I can go page up, page down. I can also search for certain things. So I'm piping it. The vertical bar is called a pipe symbol. It takes the output of the first command to serve as the input of the second command. Okay, so now I'm running, I'm in less right now. In less, the nice thing is I can use a slash on the keyboard to search for certain things. For instance, I know SSH is running on this particular computer. So now I can say search for SSH to see if any process has a name that contains SSH. And sure enough, we have SSHD, which is here. SSHD, the D stands for daemon. Basically it represents a server that is listening to a port. Okay, it's ready to respond. Okay. If I press the N key, lowercase n, it looks for the second instance. And right now, I just have two instances. SSH agent is basically an interaction agent so that we can ask, so that a GUI program can ask for password for SSH connection without having to drop down to a command line level. Okay, all right, so that's helpful. But what is even more helpful is a command called netstat. Okay, we will talk about all of these things later, so right now it's just an exposure. Netstat is a very useful command because it can show you all the ongoing connections at this point. It can also show you what process is listening to which port number and so on and so forth. So it's really useful. But from the security perspective, this particular combination is particularly useful. The T stands for TCP, L stands for listen, N stands for port number, and then P stands for, let's translate that number into the protocol name so that we can actually see, okay, I know this is port 22, but what is port 22? Which protocol is corresponding to port 22? It will also show you the symbolic name of that port number. When I press this, you can see that there's not really a whole lot to display here. It's showing you, okay, let me just go by the columns. It's showing you that TCP is the port, is the protocol. The queue is empty in this case. Nobody's making a request. Okay, nobody's making any connection at this point. 0, 0. Okay, this is the send queue. 0.0.0.0 means I'm not listening to a particular IP address. I'm listening to all connections, all interfaces. If I have like 6 network cards connected to this machine, I'm listening to all 6 network cards for incoming requests. Okay, you can set up the server to only listen to certain interfaces, but you can also, by default, it will listen to all interfaces. :22 means I'm listening to port 22. So right now I'm listening to port 22 of all network interfaces, not just one. I'm listening to all of them. Foreign addresses is basically, when you have a connection, it's just like with a phone call. When you call up somebody, that person can look up the caller ID and find out who you are. Okay, it's the same way here. Okay, if a client is making a connection to port 22 of this computer, I can actually see which IP address is originating the request and out of which port the request is coming out from too. Okay, so if you want to do limitations, you can limit by who can make the request out of which port. Typically, we don't do that, but you can. State is listen, which means we are listening to this particular port number out of those interfaces. The most important part is this part here. PID stands for process ID. A process ID is one number that can uniquely identify a process, a program in execution. And also the name of the program. SSHD is the program that is responsible to handle all incoming transmission or incoming requests to connect using port 22. So now I know something that is really important. Okay, this computer right now is listening to port 22. If you know my IP address, you can attempt to make a connection via port 22. And I know which program is supposed to respond to it. Are there any questions at this point? Are all of the concepts that I have talked about today, are they all kind of connecting? Okay, excellent. Okay, so this is seen from the perspective of the computer that I'm trying to protect. So next time, on Thursday, and potentially before that, we'll see if we can see from the perspective of a potential attacker. Okay, if someone is about to attack this computer, what would that person need to do to find out? Okay, what is the best route to attack this computer? Okay, one way to do it is called a port scan. Basically, I'm doing something from the outside, not from the inside, but from the outside. I'm poking all the network ports and find out, okay, I see that you're listening to this one, you're listening to this one, this one, this one, and this one. And a port scan can potentially also identify what operating system you're running and potentially also which version of an operating system you're running. A lot of that would be rules of thumb. They have a lot of tricks to do the identification. But once they identify which operating system you're running, which version you're running, which patch level you're running, and which port you're listening to, they can look up a table and find out whether there are any known security holes for that configuration. If they find one, guess what's going to happen next? Get ready. Get that get that CD installation CD for Windows ready, handy, because you might need that next. Okay, so we'll continue this discussion on Thursday. There's a homework assignment already online. I don't think it will take much time to do it except for the download time. But the actual part of the homework assignment should be fairly simple. I will upload the screen recording shortly after. It will be sometime tonight, so you guys can actually review and listening or to watch the entire thing again. All right, so I'll see you guys on Thursday. Have a nice evening.
Okay, so my main issue is that I'm trying to create